Hi guys, happy MEA. I'm going to be gone today. I'm headed out of town. We're headed out of town a little bit early. I'm going to try to make this short and sweet for you. Please pause where you need to. I am not going to instruct you to pause. So pause when you need to write down certain steps. You could watch it all the first time and then pause, whatever it may be. I don't care how you do it. Just make sure you get this information down in your notes. And again, pause where you need to write things down and then hit play to continue on. Unit 4, Day 8, I can write and solve a linear inequality in an inequality system to model a situation. Our first problem, you're going to want to pause after I read through it. And write it down, please. A greenhouse sells marigolds for $2 each and dahlias for $3 each. You have a total of $30 to spend. The first thing I want you to do is I want you to write an inequality describing the number of each type of flower you can buy. Remember, just think about this as parts and totals. We've practiced a lot of these now. I'm going to use my highlighter here and I look at this. Marigolds are $2 each. That is a part of the total cost. Dahlias are $3 each. That is a part of my total cost. So when I write my equation here, I have 2x plus 3y is less than or equal to 30. Pause if you need to write things down, and then I'm going to explain again why. You can see my 2x, that's my part of my marigolds, or that's the part, and that part is the marigolds, the cost of the marigolds. This green part, 3y, that's the part of the total amount of money I can spend, and that's for the dahlias. And here's the total amount that I can spend. And why is it less than or equal to 30? Well, I can spend up to $30, but no more. Now, when you graph this, that's the next step, graph the inequality. Lots of you are liking putting it in slope-intercept form. That is okay for some problems. It's not going to work in the next problem, as you'll see here in a second. But I'm going to talk you through putting it in slope-intercept form for those of you who are struggling. The rest of you may want to pause and just put it in slope-intercept form now, and then check your work to make sure you did it right. So I need y by itself. So what I need to do is I need to get rid of this 2x and bring it to the other side. And I'm going to do that by subtracting 2x to this side. And what I do to one side, I do to the other. And that's shown in this step right here. I have 3y is less than or equal to negative 2x plus 30. Y is still not by itself here. It's got the 3 with it. So I need to divide by 3 to this side. And what I do to this side to get rid of it, I have to do to this side. But I have to do to the whole thing. So you can see here, I divided by 3. On this side, that will cancel it out to make y by itself. And what I do to this side, I have to do to the other side. So I take 2 and I divide it by 3, and I take 30 and I divide it by 3. And what's left then is I'm left with, well, 3 divided by 3 cancels, and I have y. Negative 2/3 stays negative 2/3 x. 30 divided by 3 is 10. So in slope-intercept form, I have y is less than or equal to negative 2/3 x plus 10. I graphed this on Desmos, and I'd encourage you guys now to graph on Desmos just to check your work, or if you need help graphing. You can see here on Desmos, I have 10. That's my y-intercept right there. My rise over my run, I have 2 over 3, so I'm going to rise up 2, 1, 2 over 3, 1, 2, 3. Why do I go to the left? I go to the left because it's negative. I'm going to start at my y-intercept, and I'm going to go the other way now to get some more points. I'm going to go down 2, to the right 3. I draw my boundary line. I need to test a point 0, 0. When I plug 0, and I'll do that for you now. When I plug 0 in here, let's do it a little bit better. When I plug 0 in for y, and 0 in for x, this cancels this out, and I have 0 is less than or equal to 10. That's a true statement, and that's why I shade on this region with the test point. And those are the notes from yesterday, so make sure you check those out. If you don't have those done, get them from a partner. The next problem is a little more intensive. I have 7 minutes here until the bell rings to do it for you, and that will make it hopefully short and sweet. All right, so first, I know it's a lot of words, so take it a step at a time. Let's read through it before you start writing. A store orders wooden chairs hand paints them, and sells the chairs for a profit. A small chair costs the store $45 and sells for $80. A large chair costs the store $70 and sells for $100. The store wants to pay no more than $2,000 for its next order of chairs and wants to sell them all for at least $2,750. Again, parts and totals here. A small chair costs the store $45. That is part of the total cost. So they want to pay no more. That's their total cost. So a small chair's cost is $45. That's part of the total cost for small and large chairs together. It sells for $80. So a small chair will sell for $80. That is part of the total sale. Okay, let's keep reading. A large chair costs the store $70. Again, that's part of the total cost for the chairs for the store. They sell it for $100. That's part of the total cost. Okay, now what I want you to do is pause this and write it down. If you were writing while I'm talking, make sure that you understand what I just said. So rewind if you need to. Okay, so the directions are, you've hopefully paused by now and written everything down, is we need to write and graph a system of inequalities that represent this situation. So please take time, write this down, pause, and I'm going to set up the system of inequalities right now. I signified X as small chairs and Y as large chairs. Ignore my table here on the right. Let's just look at the first equation. You can see I have the 45X. That's the cost for the small chair. Plus I have 70Y. That's the cost for the large chair. Has to be less than or equal to 2,000. That's how much they want to pay for, that's their total cost they want to pay. They don't want to pay any more than that, and that's why it's less than 2,000, or it's a less than or equal to. They want to pay no more than $2,000. That's the most they want to pay. So this 45X plus 70Y has to be less than or equal to $2,000. Okay, next equation. 80X plus 100Y. So 80X is the sale of the small chair plus 100Y, the sale of the large chair, has to be greater than or equal to 2,750. Their total sale, and they want it to be at least 2,750, which means they would like it to be more, but if it's at least that much, they're happy. This is why we have a greater than or equal to here. Now, one more thing, when we jump into systems of linear, I'm sorry, excuse me, let me back up. When we jump into linear programming next week, you are going to have to set up a little bit more with these problems. In the real world, we can't have any negative chairs. So we say X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. Write everything down. If you have any questions, pause it and write down your question in the margin, and I can answer it on Monday. Okay, now there's a reason I put this table over here. If I put these two equations in slope-intercept form, it gets very messy to graph. Yesterday, I talked about this. When we did a system, I said use colored pencils. So in the front of my room, there should be colored pencils. You can go in my cabinet and get them if you need to. You can put this in slope-intercept form. Again, it's going to get very messy. I really want to encourage you, especially when we do linear programming next week, to use that table. So practice it now, where you put a 0 in for Y. So for this yellow equation, if I put a 0 in for Y, this would go away. And I'd have 45X is equal to 2,000. And I solve for X, and that value goes right here. I'm going to take away what I just crossed off. Again, if I did it here, if 0 is X, this whole term goes away. I'm left with 70Y is equal to 2,000. I solve for Y by dividing by 70, and whatever I get, that value goes here. I repeat the process for this equation. Again, practice it. I'll help you with it on Monday, but it's really going to be valuable for linear programming to graph this way. Otherwise, it just gets super messy. Now what I want you to do is I want you to practice graphing these in Desmos just to check your work. And Desmos is, just go to desmos.com and I'll show you. And when you go on there, you just start graphing. And so you can graph any line you want. So 2x plus 3y. And you'll note down here, here's all our inequalities is less than 12. And it will do that with the shading with you. So do that to help you practice. Again, you want to get used to knowing how to plug in a test point and all of that. But this is just a nice tool to use to check your work. So what I'd like you to do right now is I'd like you to pause the video and I'd like you to practice graphing this how we did yesterday. We're going to graph each one using a different color. We're going to take a test point. We're going to shade and we're going to see where the shading overlaps. And where the shading overlaps, that's going to be where we're going to really darken the area. Again, refer to your notes from yesterday if you need to. Talk with a partner if you need to. Now what I did is I graphed this all in Desmos. And you can see the graph. Oops, it must be on my next page. You can see the graph right here. So I have all the values in Desmo here. And they color code it for you as well. The only thing I don't really like about the Desmos is it's really hard to see what is the correct answer here. So what I did just to double check, I thought it was this area in here. But to double check, I tested a point. I took 40, 0, which means, oops, sorry guys. I'll just use, I took 40, 0. And I just made sure if that really is a solution, it should work for each equation. So if I plug 40, 0 in this one, it's a true statement. If I plug in 40, 0 into this one, it's a true statement. If I plug 40, 0 into this one, it's a true statement. And if I plug 40, 0 into this one, it's a true statement, which just confirms that the overlap is right here. Now, if you're doing it on your own with your graph paper, I would suggest if it was a struggle for you, that you should use a scale of probably 5s or maybe, yeah, I would go by 5s, maybe 10s. This one was a more difficult problem. Again, just going back, let's kind of summarize what we did. We wrote our equations. Then you practiced graphing it on your own. If you struggled, check your scale. Was it your scale that was a struggle? Did you put it in slope-intercept form? Did that make it a struggle? Where did you struggle? Did you struggle with the test points and figuring out which way to shade? Write down where you struggled and make sure you bring it up to me on Monday, and we'll spend a little bit more time on it. This whole concept we'll be working on next week with our linear programming units. We'll get a lot of practice with it. At this point, I'm going to sign off, and I'm going to say make sure you're working on your practice, doing any Schoology learning target checks if you haven't done that, and being good for the subs. But most of all, hopefully you enjoyed your Tootsie Roll. Have a great day.